Hello everyone. In today's video, we'll be learning about Bohr model of atom. Niels Bohr, whose full name is Niels Henry David Bohr, was a Danish physicist and was born on 7th October 1885. He proposed his model of atom in 1913, and in recognition of his work, he was awarded Nobel Prize in Physics in 1922. Before Bohr, Rutherford proposed a model of atom according to which the entire mass of an atom was concentrated in a tiny positively charged nucleus around which the electrons move around in circular orbits. The Rutherford model was, however, not in conformity with the classical model of electromagnetic radiations. A moving charged particle will emit radiation, will then lose kinetic energy, and eventually will hit the nucleus and perish. So, Rutherford model was not successful in explaining the stability of an atom. Bohr retained Rutherford model of a very small positively charged nucleus at the center, which contains all the protons and the neutrons. Bohr also agreed that the negatively charged electrons are revolving around the nucleus in the same way as the planets are revolving around the sun. But he took a bold step forward by applying Planck quantum theory to the electron revolving around the nucleus. So remember that Bohr theory is based on Planck quantum theory. So let us try to see the main postulate of the Bohr model of atom. An atom consists of positively charged nucleus responsible for almost the entire mass of an atom. That is what I have explained, that he retained the concept of positively charged nucleus, which was given by Rutherford. The electrons revolve around the nucleus in certain permitted circular orbits of definite radii. If you try to picturize this, it would something look like this. The electron will be revolving around the densely positively charged nucleus, which is present at the center. Now, the question is, how does the electron decide that which particular orbit is permitted? To do that, the permitted orbit are those for which the angular momentum of an electron is an integral multiple of h by twice pi, where h is the Planck constant. If m is the mass and v is the velocity of the electron in a permitted orbit of radius, then L will be equal to mvr, which is the angular momentum, equals to n times of h by twice pi, integral multiple of h by twice pi, where n can be any natural number, where L is the orbital angular momentum and n is the number of orbit. The integer n is called the principal quantum number. This equation is known as Bohr quantization postulate. So, according to Bohr model, only those orbits are permitted in which the angular momentum of the electron is a whole number multiple of h by twice pi. If it is not, then those orbits will not be permitted, or electrons will not be revolving around those orbit. In other words, we can say that angular momentum of electron in an atom is quantized. It is fixed. The next postulate says, when electrons move in a permitted discrete orbits, they do not radiate or lose energy. So according to Bohr, the electron, if it is revolving in a permitted orbit, then they never lose energy. Such orbits are called stationary or non-radiating orbit. Okay, we call it stationary orbit because the energy of those electrons will be fixed. They do not change when they are revolving around that particular orbit. In this manner, Bohr overcame Rutherford's difficulty to account for the stability of atom. That is what Rutherford failed to explain. Rutherford failed to explain that why an electron revolving in an orbit does not lose any energy. Okay, so Rutherford explained it in this way, that the energy of an electron is always fixed or stationary. Okay, it does not change if it is revolving in that particular orbit. That's why the orbits are also known as the stationary states. It was found out that as you go higher in the orbits, the energy associated with the electron will also increase, or the energy level will also increase, or the orbits will also increase. The different energy levels were numbered as 1, 2, 3, 4. So as you go from the innermost to the outer orbital, it will be numbered as 1, 2, 3, 4 and reaches till infinity, and also designated as K, L, M, N, and goes on. So if you try to picturize this two concept or this two postulate, this is what we can say. Okay, so you can see the various orbits. The energies are E1, E2, E3, E4, E5. It can go till infinity. And remember that E5 will be greater than E4, E4 will be greater than E3, E3 will be greater than E2, E1 will be the least one, which you can see in the bottom right. The angular momentum will always be quantized for that particular electron which is present in an orbit, and that is nothing but angular momentum mvr will be equal to nh by twice pi, which you can see on the top right corner. The orbits are called stationary states, and the orbits are numbered as 1, 2, 3, 4, and that is nothing but the value of n, and n is nothing but principal quantum number. The same principal quantum number or the value can be designated as K, L, M, N, O. So if I say N shell, what I mean is the principal quantum number is 4. So what is the main important point in this is, as long as the electron remains in a particular orbit, it will never lose or gain energy. Okay, this means that energy of an electron in a particular orbit always remain constant. Okay, that is the reason why we call them stationary states. Okay, moving for the next postulate. Ordinarily, an electron continues to move in a particular stationary orbit or state. Such a state in an atom is called the ground state. As we have discussed that whenever we talk about an atom have actually stationary states, the energy levels, and the electron in it will always revolve in that stationary state. When energy is given to the electron, if some external energy is given to those electron, it jumps to any higher energy level and it is said to be in excited state. So when an electron jumps from the state where it is present and goes to higher energy state, how it can go? When you supply a definite amount of energy. When the electron jumps back from the higher to lower, always remember that the electron cannot be present in the higher. It will always be unstable. Whenever we say higher energy, it means instability. Lower energy leads to stability. So when we give energy to an electron, it goes up to higher energy. But since it will not be stable in higher energy, it will come down by radiating the energy which it has absorbed while going up in the orbit. So we can visualize this in this way. You can see two energy levels, N1 and N2, having energy E1 and E2. When it wants to go from E1 to E2, the electron, then it must absorb a definite amount of energy. It is not that it will absorb whatever amount of energy given and go up. If an electron has to go up from a particular orbit to a higher orbit, it must absorb the energy difference between the two. In this case, if it is going from N1 to N2, it must absorb energy from energy which is the difference between the E1 and E2. That is delta E, which you can see in the right hand side, is E2 minus E1. That much energy has to be absorbed so that it can go to E2. Now, if the electron will go to E2, then it will be higher energy, it will become unstable, so it wants to come down. So while coming down, it will radiate energy, and the frequency of that radiation can be calculated by using the formula which you can see on the left hand side. Nu will be equal to E2 minus E1 by h. That is nothing but used from Planck quantum theory, because we know that according to Planck quantum theory, E is equal to h nu. By using that formula, we can get nu is equal to E2 minus E1 by h. So if we try to see all the things together now, so that is what actually we can make a Bohr model. That is how actually a Bohr model would look like. Okay, so according to this, so we'll have a infinite number of energy levels. Okay, in that infinite number of energy levels, the energy levels will be numbered as n1, n2, n3, n4, or it will be designated as k, l, m, n. Each will have a definite amount of energy. That's why we call them stationary state, e1, e2, e3, e4. Why do we call it stationary state? Because the energy of an electron in that stationary state always remain fixed, constant, which you can see in the bottom right. Energy of the electron in stationary state is equal to minus RH. RH is the Rydberg constant. We'll be coming into it once we come for the success of Bohr model, into 1 by n square. N is nothing but the orbit. So the energy is decided by the orbit. So if it is present in a particular orbit, the energy does not change. Okay, what we have learned is the angular momentum will always be fixed, which we can see in the top right, where mvr is equal to nh by twice pi. It will be always an integral multiple of h by twice pi. If an electron jumps from the lower energy level to higher energy level, which we can see in our right side, then delta E will be E3 minus E1, since over here it is jumping from E1 to E3. And if it comes back, then it will radiate the energy or the frequency, which will be E3 minus E1 by H. So that is how we can understand the Bohr model of atom. Now, what were the success, or what are the things actually Bohr model can or could explain? So the success of Bohr model. Bohr theory satisfactorily explains the spectra of species having one electron, namely hydrogen atom, etc. Calculation of radius of Bohr orbit. According to Bohr, radius of nth orbit, any orbit in which an electron moves is, so he calculated Rn will be equal to h square by 4 pi square me square k multiplied by n square by z. So that was the formula derived by Bohr, where n is the orbit, m is the mass of electron, e is the charge on the electron, z is the atomic number of the element, and k is the Coulombic constant. After putting the values of all the constants, since most of the values are constant over there, what do we get is Rn will be equal to n square by z. N depends upon in which orbit the electron is present. Z depends upon which atom we are talking about. So if we put these two values, then the radius we can easily get it. Okay, so if we try to put this value for hydrogen n is always equal to 1. The electron is present in the first orbit, and z, atomic number of hydrogen, is 1. So n square is 1 square, z is 1. So it becomes 1 by 1. So the value of the hydrogen orbit will come out to be 0.529 angstrom. That particular value we call it as Bohr orbit also. Coming for the more success of Bohr model, calculation of velocity of electron. Bohr could calculate the velocity of electron. So Vn will be equal to 2 pi e square zk by nh, or Vn can be written in that way. Okay, which actually gives you the value of that 2.188 into 10 to the power 8 by n. Okay, centimeter per second. Calculation of energy of electron in Bohr orbit. We can calculate the energy as we have discussed also. E will be equal to minus 2 pi square mz square e to the power 4 k square by n square h square, where if I put the values in urge per atom, what I get is 21.8 into 10 to the power minus 12 z square by n square. In terms of electron volt per atom, we can get it minus 13.6 z square by n square. 1 electron volt, as you know, it is 1.6 into 10 to the power minus 19 joules, which can be converted easily. It could explain the hydrogen spectrum on the basis of actually his model. Okay, so hydrogen spectrum could be explained in a very nice manner by using the Bohr model. So this were the success of Bohr model. Even though Bohr model could explain many things, but still there were some drawbacks of Bohr model, or the failure of the Bohr model, or the limitation of Bohr model. Bohr theory was very successful in predicting and accounting the energy of line spectra of hydrogen, that is one electron system. It could not explain the line spectra of atoms containing more than one electron. Remember that Bohr model is for one electron system. It cannot explain the spectra of atoms which contains more than one atom. Okay, so Bohr model is for hydrogen atom or hydrogen-like atom which consists only one atom. This theory could not explain the splitting of spectral lines in magnetic field, Zeeman effect, and the electric field, that is Stark effect. This two effect could not be explained by Bohr model. The splitting of spectral line could not be explained by Bohr model. The major limitation of Bohr model came from this particular concept or the theory, that is what we call as de Broglie equation or de Broglie concept, according to which what he actually said is the electron or a matter will always have a dual character, that will be the wave character as well as particle character. According to Bohr model, electron was considered as a particle, not as a wave. So Bohr theory could not explain the wave nature of electron. So he could not, or he was not able to explain the dual nature of matter, okay, or the electron. The next limitation is this theory could not explain the Heisenberg uncertainty principle, according to which the momentum and the position of a moving subatomic particle cannot be found out precisely. But Bohr model was against this particular principle. If you try to see the Bohr model, according to Bohr model, we can find out the momentum of an electron and also the distance of the electron or the position of the electron quite precisely, which is not possible. So this were the failure of Bohr model. So that is all about the Bohr model of atom. Thank you everyone. Do subscribe for this channel for explanation on various topics in chemistry. Thank you.